happens over here. I am going to try and break everything with drawing again. All right, we're just going to do that every time until I have something that works, because next week I need it to work. Get the camera. I'll just force it by hand over there. I think we're live. Twitch looks reasonable. All right. Bam. Does that work there? It does. All right. Today is the 26th of September. We are wrapping up ROP here in CSE466. Memes. People seem to enjoy my live demos. My live demos are really live, as we found out late last Tuesday. I'm going to break things again. I'm going to try and draw for no reason other than seeing if it works. So we'll find out. Somebody says, this shall be my only, and then I don't get to see what the original message was. That's cut off for me. I joined my own stream too late. This shall be on my, I don't know. All right, you gotta hit that again if you want me to read it. We're gonna try and draw again. I'm glad I'm entertaining. Details matter in just this whole course, this whole topic. So this was an amusing meme because, of course, you're placating to me. And you're saying, hey, I use replace new line with an empty string. Rob uses strip new line. Turns out both of these are actually not the correct approach to use. If you want this to be as bulletproof as possible, why? It can break. It can break. That's a pretty safe statement in like most code that you could write. But why is what we're attributing to me here, receive line strip new line bad? All right, nobody knows.
I mean, why rest? Has there be a period to strip when you visit it?
So there's an assumption here. Let's see. Make sure I don't cut my own head off again. The assumption is that the process, like we've read enough input, we have some byte string that is something like this, right? It is, and then there's a new line character. And this is what the result is that we're going to read from a process, right? And so what I want to get here is whatever these bytes are that go there. There should be 6 of them. I don't know if there's actually 6. I just kind of YOLO'd it there. Did I give it 7? It seems to think it's 8. Okay, whatever. We'll give it that. So this is roughly what you would try and get from a challenge. You're going to get some garbage bytes, and then it probably, because you're calling like printf, and it's outputting some bytes with a new line, right? Yes, so Twitch called it correctly. The case that I gave here will behave as you expect, right? Result strip removes just that new line character. The problem is are there any restrictions on what the least significant byte of this address that I'm leaking is? No, it could be anything, right? Because this is just a number. And so that means, in theory, there's nothing stopping the last byte of this from being, for instance, hex 0A, which hopefully my memory's working correctly. Well, if that least significant byte was OA, that OA is now gone. Why is OA gone? It is. So the statement from the class statement. Okay. We see up there at the top, hex 0A is a new line character. So if that address or that thing that you're trying to leak ends with a new line character and you use strip, strip will remove all of the new lines, not just the first one. And so the correct way to kind of pull this out is what I did originally, which is to say, I want to read in all of the bytes, right? I want to take that byte array and I want to drop the last byte. That's what this syntax is. It's called Python slicing. I'm saying, give me everything and then drop the last one. and this gives me that. Here it's displaying it as /n, but that is in fact that same character that I entered. Where did I put it? Right here. That's that OA, right? And so I only dropped the extra one. So there's a right way to do it, and it's not what I did on Tuesday. This other one here, I didn't get this meme when I saw it, and I still only kind of get it. It turns out a subset of the class has discovered some. You guys are really good at searching. I don't trust your magic there, Twitch. People are really good at like searching through the Discord for like ancient conversations, since that hasn't been purged. And somewhere, someone on the Discord said, "Hey, you can use jump RVP." And that's like, okay, well, what does that mean? I don't know. If you read the thread, I guess it talks about if you're trying to find a gadget in libc, there's a jump RVP gadget somewhere that you may or may not be able to find, and you can use that by brute forcing the least significant bytes of a return address that's in libc. Maybe that works, maybe that doesn't. I don't know. I can tell you that's not necessarily what's immediately intended there, to just like blindly shoot for gadgets, because people are doing this on challenges where it certainly wasn't intended. But that's okay, right? Flag is flag at the end of the day. It's kind of a silly approach, in my opinion, when you can use a more like logical and reasoned approach instead of just writing this for loop and then like, oh, I hope I hit it. That seems kind of silly to me. I really liked this meme because this is something that I personally really believe in. It's cut off on the Twitch feed here, but it says when someone finally asks the right questions, and then they're going to watch this thread with great interest. I watch a lot of threads, even when I don't respond to them. I usually like glance at it and see what's going on. As long as people are talking, it's fine. And I am a big believer of like how you phrase your question matters a ton, right? If you phrase your question where you are asking conceptual questions and you are articulating something clear that is answerable, then you'll probably get like a detailed response that is useful. And if you ask something like, hey, this is level 4 and I don't know what's happening at segfaults, it's probably going to be a lame conversation. Not only because it's unlikely that I'll respond, but other people are also unlikely to respond. And so that doesn't reward the class as a whole. It's not a net beneficial thing. Yeah, somebody else on the Twitch here says that they too do not answer poor quality questions. So phrasing your question right matters a lot because it does end up with more useful discussion. Memes, 2 ways to pivot. I actually don't like the meme on the left or meme on the right, but we're going to go with it. It was a nice way to frame this. So a stack pivot is essentially just setting RSP, sending RSP to somewhere else in memory. And so this is what we talk about when we're talking about ROP and doing a stack pivot or pivoting. Some other people had got to that point because that's right around where the checkpoint is, and they pivoted in a very different way and decided to go work on other coursework. All right, like I get it. It's actually kind of clever. You're not going to get the upvote for it, despite it being on the slides, because I believe that you can do better to the author. However, yeah, all right, that's fair. If you try and solve all of this at over the weekend here, last minute on like Sunday, Monday, good luck. So where are we so far with ROP? We have like the weekend to go. Average student in the class that is actively participating has 56% of the ROP module solved, which means they're still on roughly level 9, like 8.59, somewhere around there. Means that they're working on stack pivots. Okay, like that's fine. Then there's not a whole lot of change from where we were at the checkpoint, which is also fine because I imagine people are just waiting for the weekend. It's not like, hey, I'm hard stuck. Like you manage your time. Yes, I'm not going to talk about stack pivots today. I talked about stack pivots on Tuesday for that like 10-minute window. If you're like, hey, that 10-minute window wasn't enough, I agree. Which is why at like 7 or 8 o'clock that night, I just randomly streamed on Twitch again, took the exact same binary that we had from Tuesday, and plugged along until we pulled off a stack pivot and made it make sense. If you just want to get like the TLDR on stack pivots, go to that same video, whatever the class video is. I just stapled on what I did in the evening to the end of it. So now it's like a 2-hour video instead of the hour that is class. And go to the very end, like the last 15 minutes. The time in between there, the first like 40 minutes, I think is worth watching if you want to try and see like how to reason about things, because I didn't know if I was going to successfully get a pivot out of it. And so we were figuring out like what was going on in the binary. There were some interesting seg fault things that I didn't expect. You know, more of these kind of like happy accidents like we had with the null byte being the least significant byte of puts when I started the demo on Tuesday. Like things like that will happen, right? And more of those type of things happened as I was marching through this demo that I like threw together on this fly with you, right? But I did work around them and we reasoned about the behavior that we saw, and we were able to finish it out and successfully pivot. We could have turned it into complete control flow if I wanted. So if you're interested in that, check out the last 15 minutes. This right here, I dumped on myself because I was doing that stream at night and I was not a canned thing, right? So I was still just working on that random binary. And I was like, oh, this will pivot, and then it didn't pivot, right? And so I had a moment where I myself was like, okay, what's going on? It wasn't intended. I did in fact figure it out. So if you want to see like how I was problem solving, it's worth taking a look. Dynamic allocator misuse launches tomorrow, right? The show must go on. This module is considerably different than what we've seen so far. We're still dealing with the concept of memory corruption, right? And that's going to be a consistent theme. But we're going to start dealing with a lot more pointers. This is specific to heap. I don't believe we're going to do a whole lot of pointer stuff in the other modules based on my recollection. But it's one of the things that I think is important to have in this class in 466 that was missing in some prior iterations. Is everything that 466 did for past couple iterations was everything started from this buffer overflow, and it's just like, all right, everything is in linear memory, right? And I think that's kind of lame, and it does you guys a disservice. So like one of the things that people asked about ROP was, all right, well, what if there's a canary? And there's some challenges in this ROP module that have a canary, right? But they're also like fork servers, or they give you some like arbitrary read primitive. They're like, give me an address and I'll tell you what's there, right? It's cute, but that isn't necessarily what happens in, real exploitation. More often than not, you don't just overflow from the stack over to the saved return address. Instead, you target some other subsystem, some other subcomponent or behavior that exists within the program, and you turn that into a primitive. So I think it's level 13 or 14 of ROP. One of them says, give me an address and I'll tell you the bytes that are there. What is it? 13? So that idea isn't actually that far-fetched. All right? That concept of address, tell me what's there, is something that's called an arbitrary read. Right? That's like a fundamental primitive when you're thinking about exploitation. It's how do I get the ability to arbitrarily read memory? Right? And one of the ways that you can get these primitives, like arbitrary read or arbitrary write, which is a similar thing, give me an address, put the value there. One of the ways that these primitives are generated is by exploiting the heap. So the heap is a very common thing when you need memory dynamically allocated so that it isn't on the stack. And so this is going to move us away from this realm of we read in here and then we just go forward in memory, which I think is going to be super cool and interesting. Using GDB, and specifically using a GDB plugin like Jeff or pwn.debug, is borderline mandatory to reason about these. So if you have stubbornly said, I'm not going to use either of those, now is the time we're going to pay the piper or figure it out. Like you can deal with it by looking at using basic GDB commands, but it's going to be a whole lot of pain. And then one thing that I'm going to warn people about just right now before this thing launches is the heap module is The difficulty ramp for like the last, I'm going to say 4 levels, I want to say it's like level 16 onward, there is a huge change. So there's the Yon videos that you're probably familiar with. That covers everything up until I think level 15. And then you're going to get like this bonus video that I made, right? It's not new for this class, all right? I added these things a while ago. But you're going to get this bonus video that's going to be, hey, this is Robert from the future. And it turns out, you know, in the past couple years, what Jan said is correct, except this. And there's this protection mechanism called safe linking, which will be a jolly good time for all. And that makes heap stuff way harder. And so like level 16 onward are going to be significantly more difficult than the earlier challenges. I'm letting you know that now, so that way if you like start on it, you're like, hey, this is easy, like that's great. Just plan your time accordingly. Plan the later quarter of those challenges to take up probably most of your time on the module, if you plan on completing them all. Somebody asked a couple weeks ago if I could launch modules earlier. There actually was no reason that I couldn't. I just didn't get around to scheduling it in time for ROP. So tomorrow, I did already change it on the dojo. It's going to go live at 3 p.m. instead of 6 p.m. There's no major changes from the existing content. I'm not even going to like lie to myself that I'm going to change stuff on you. We're just going to rock and roll with what we got. Okay. With that, I actually don't have any like big plans, big topic, something that I wanted to like show you guys today. Stack pivoting, I could have like finished stack pivoting today, but like that seemed kind of unfair, which is why I YOLO'd it on Tuesday night. So is there something that you guys want me to ramble about? Can you phrase that another way so that I know I have it correctly?
Let's say you have this like a buffer leak that a lot of scientists do have. Now you want to set up a base address for your expert that you're writing. How would you teach them about that?
So just how would I ROP if I don't have a leak?
Not just without a leak, but yeah, in a way. Because we any guidance that we do find, it's going to be because of AI randomized, it's going to be before levels will be working. So how would we create a ROP?
Do I get to assume that I have like a fork server or something like that? Is this something you actually deal with in a challenge, or is this something you're hypothetically throwing at me?
Something similar to what I did in a challenge.
I think you're mistaken. All right. I'll think about it. Oh, okay, we got something here. Oh, it's going to be another poorly worded question, but I'll go with it. All right. So Twitch is saying, trying to do lib2c. These things have like crazy names. People say things like ret to libc, and I'm like, I don't know, man. People have reused these terms and like recycled them so often that I don't have a definition for these things. Lib2c at level 13. I have the address of start. How do I get puts got and puts plt? Is your question in reference to level 13 by chance? Okay, so I'm not gonna like solve level 13, but no, like Twitch said my bad. So I get what you're asking. It's just anytime that the question is phrased in the form of like level X, blah, that just feels bad, man. Okay. What are we doing here? We are going to pwn.college. I'll take a look at it just so I can think about it correctly. Who are we? We are ROP, and we're looking at whatever. We'll do 13.1. ROP function has a canary. What does this thing do? Okay. This gives me a leak of my input buffer. Do we know where this is located? What? So I'm just running 13.1. I could have ran 0.0, but like, what one seems like more fun. So it says your input buffer is located at this address. Where is this address in memory? Why do you say that?
If I take that address as GDP and repeat map markets.
Okay, if I were to GDB it, it would be on the stack. Okay. You could also know that because, like, by convention, the 7FFF is typically on the stack. But what is this next prompt?
An address that I could tell, and it's going to tell you what the address points to.
Okay. All right. And then the next thing I want to do here, we're gonna hit the danger zone. I'm gonna finny from the read. I'm gonna give me. Is this gonna blow up or is that gonna work? It's 2 reads. Address to read from OX1337. Okay, I need a whatever. We'll run this. I'll just give it the address that it gave me. I know this is valid, right? This is something on the stack. Read from there. All right. And then the next thing that it's going to want to do, I imagine, is it's going to read into that. Okay. So that's interesting. So I get a stack leak, which I know is where my input is. And I get an overflow. Does this thing have a canary? You say yes. Okay. So I know I have to use, if I'm going to try and rock or overwrite the return address, I have to get past the canary. I have to use that read for the canary. Yeah? Okay. So then the next question is, where do I want to redirect control float to? Right? If I can get to the return address, what do I want to put there? Does this challenge have any hint? It just says perform a wrap when the function has a canary. All right. So let's run this guy. And what I want to get to go and snag whatever it gave me. I'm just putting in something valid. I want to get to this function frame. So where am I? I'm inside of main. And what we see here is that there's no challenge function, right? If I were to info func challenge, does that exist? It's just main. Okay. And if it would have existed, I would have gotten something like this. Okay. So that means that the thing that I can overwrite is going to be whatever this is, right? This is the saved return address. I could overwrite 2 things. I could overwrite saved RBP, and I could overwrite the saved return address. Yeah? Question?
What is the save return address? Generally, when you call a function, then you save the return address. In this case, there is just a main. So why do
Okay. The question for Twitch is the reason that, hey, I'm thinking about saved return addresses, and saved return addresses only exist if a function was called, right? But I'm in main. So why do I have a saved return address? Yeah? And the answer is, like, main is the first thing that we think about as programmers, as the entry point of our program. But it turns out, when programs are started, main is not actually the first thing. It's not just like stuff has to happen to load. How does this elf get into memory, right? Like something has to do that, right? And the thing that does that is actually the loader. So the first thing that starts up when you do like /challenge/ whatever is the loader, and the loader's job is to then be like, okay, here's this elf. Where does it go in memory? Where's its dependencies? Where's libc? Let's throw that in there somewhere, right? And then it ends up going into, I believe, libc. The loader passes it off to libc. And then libc calls a function called I think it's underscore libc start main. If I'm remembering right, we can find it if we want. I just don't want to lose my place in the debugger right now. And that is the thing that calls main. Now, when I look at a backtrace, not stab, GDB is just telling me main's the only thing that matters, because if I'm normally debugging, that I don't really care about what happened outside of my program, right? It's kind of unusual to want to debug what happens prior to your program. It certainly can happen. If we were to examine the address that's there, look, we get, I did have it right, underscore libc start main. And so if we look at where is this, it is in fact inside libc. And so the loader starts up, it throws a whole bunch of things into memory where it needs to go. It's going to call some function in libc that eventually calls libc start main, and then libc start main calls main inside the elf. If we were to disassemble libc start main, I gotta scroll up a little bit. There's gonna be this weird line. E98. Am I going in the correct direction? Oh, no, I don't want that. I want the address at E98. I printed it. Whatever. We'll grab it right now. Examine the address here. Okay, 083. Okay, this call RAX. This is calling main. So this is the line, the assembly instruction inside libc start main that calls main. Now this is typically hidden from us in the debugger, but we can see it if we really want to. Another way to get there is there's a difference between start, which will run it until main, and then start I, which will run the binary and then break at underscore start in the elf. If you do start I and then start doing step instructions, you can see the loader throwing stuff into memory and step all the way through to libc. Because this is saying start I is run the binary and start at the very first instruction. And so it depends on what you want to run through. But something does in fact call main is the takeaway there. I'm happy to derail whatever, because I'm really just kind of filling time unless you guys hit me with something. Somebody said, I realized I don't need as much info as I thought. Okay. Was libc start main useful? Did this rant solve Twitch's question? I have to give a moment for the delay. Did you learn anything useful?
I kind of knew what to put in the read address so that I get what I want for the initial read. What I was wondering was, like we have an input buffer address that is very useful to us for writing the exploit, but when we run any log gadgets on it because of ASLR, we only have the last 4 levels of it. How could we use that without setting up any base addresses?
Okay. I'm going to try and paraphrase. Cool. So this is my address that is located, that is my saved rip, right? If I were to examine the giant hex right there, info frame, we see E98 is where my saved rip is. I'm examining the address that is there, which is this thing, which is do you agree? Okay. Which is an address inside of libc. And you say, when I'm looking for gadgets, what do you use? All right, you use wrap gadget. I run wrap gadget, and I say, I am interested in, are you running it on the binary? Okay. I'm running this on the binary, and I'm looking for, I don't know, pop. Let's just do leave, because I know that'll be there. And I get this. Rock Gadget tells me 1DF5. How do I use this? So the answer is, which is what the class said. I need to figure out the base address and then do some math, right? But this sounds impossible, because we saw that the challenge, as soon as I do that, it quits, and I don't know how do I get this base address, right? I have this like chicken and egg problem. Well, what's something that we did in memory corruption that may apply here? I don't think we loop. Okay, we recurse to memory corruption, but we don't have the ability to recurse here, as far as I'm aware, right? There's no. You're talking about like we pass a secret word and it calls itself and does something like that. We don't have that power here. The binary doesn't do that.
None of the binary has that power.
As far as I'm aware, none of them in this module have that power. If they do, reverse it and find out, but I don't believe they do. Okay, so you say, all right, I could restart it. When I say restart, I assume you mean like I'm calling main again or calling start or like doing something like that. And maybe that's what you were going for too, right? I could jump back to the beginning of the binary. Yeah, that would make sense, right? But I can't jump to the beginning of the binary unless I have the base address of the binary, right? But I don't. What do I have? I have one piece of information that I'm not like leaking, but I like implicitly have it. What's that? Right. It's not a leak. I don't have a libc leak. But what is in the saved return address right now, which is the thing that I have been dumping out? This address, right? Does this address already deal with PIE and ASLR, right? Yeah? And so what did we do in like memory corruption when we had one of these ASLR addresses and we wanted to overwrite it? What was our strategy? So something about the last nibbles. Something about looping and nibbles and last. Like, come on, get me there. What did we do? Thank you, ending with Ali. For rating, we got a rate of 95 people here. We're hopping on Science Twitch right now.
When the ASLR was that initial approach was to just passing the 4 bytes to override the last 4 nibbles, and we get a 1 out of 16 chance of getting it right.
Okay, that's close enough. There was some terminology off there, but the thing that we're going for was we could do a partial override. Right? Because when we are overwriting on the stack, the first thing that we overwrite is going to be this 8-3, right? That's the least significant byte. We have to overwrite whole bytes. We do not have the ability to overwrite a single nibble. And a byte is 2 hex characters. Now, is this something I can use in this context?
But that's for main.
That's for... And what? So this is from the binary. This is from the binary? That's what this address is? Right. So when I looked at it, the return address, which is why this was a good question, is where does main return to? Right? The return address is a libc address. So if I want to partially overwrite this return address, do I want to overwrite it with a binary's gadget? No. Right. We look right here. The binary has a totally different randomized bytes of the address compared to libc. So instead what I want to do is I want to say, well, what gadgets have most of this address that is the same? That's what I'm interested in. So how do I figure that out? Get the libc that's used for this binary. What's your preferred way of doing this? LDD? Okay. So you can run LDD on a user-land binary. It's going to show you how the dynamically linked libraries will resolve and where they resolve to. You could also get that from the good old GDB VM map. LDD is honestly probably quicker. So then we wrap gadget on the libc binary. Now this is going to take a little bit longer because libc is considerably larger than the userland binary. If you intend on running wrap gadget many times, right, you're going to look for a lot of things. My strong recommendation run it once with no filter, dump it to some file. I'm just going to call this libc gadgets.txt. And now, instead of having to run wrap gadget a bunch of times, I can cat libc gadgets and then grep it for what I want. And that's way faster, right? It's a way faster way of getting, because I don't have to like reparse all of the binary to get the gadgets. So that's something we could do. But then the question is, well, these are quite long, right? And so before we had these locations, and I'm not saying that we want to go to any of these, we're just like talking abstractly here. They're like, take this bad boy. We said that 3 nibbles are the offset into the page. And in a happy scenario, you have a 1 in 16 because you're brute forcing 1 nibble. This gadget has 3 nibbles plus 3 more nibbles that would need to be brute forced. Do we have a guarantee that these higher order 3 nibbles are 1,2A? No. This 1,2A is being added to whatever the base address happens to be. And so if we run this, one of the nice things that we get here is it also tells us where, in theory, we're going to like base libc. And so libc could be here, at which point that giant gadget is going to be whatever, or that gadget is going to be whatever that large number is, plus this base. Or it could be this plus that base. And so we actually can't deterministically say what those next 3 nibbles are going to be. So we could do that. Right? We could try and brute force that. We're just going to run this bad boy, in an infinite loop. And what are our odds of success? How do I calculate it? It's not that large. All right. Like it is doable. So the question is, like, let's think about what is the actual math involved on that. I have 3 nibbles that I need to brute force. How big's a nibble? Nibble's half a byte. How big's a byte? 8 bits. So a nibble is 4 bits. I think you're wrong, Twitch. If I'm wrong, then hopefully everyone else corrects me. So I have 3 nibbles that I need to deal with, which is going in. Sure, each bit is two possibilities, right? It's a 0 or a 1. So that means that I have 12 bits that I need to brute force. The answer should be 2 to the 12. That is not how you do powers. Is it star? It's oh, I broke Python. Okay. 2 star 12. Okay, that's not bad. It's actually 1 in 4096. Right? It's not intractable. Yeah, somebody got it right here. All right, 2 to the 12. I have higher hopes for you, Mr. 2 to the 24. 4096 isn't that big of a number. Yes.
This is only if we can keep our program running, our binary running.
Well, no. So the statement for Twitch is, well, this number is only true if I can keep the binary running. So you're thinking about something that's correct, right? The binary exits. If I guess wrong, it just blows up and it leaves, right? It'll either exit violently or exit cleanly. More than likely, it'll violently exit. And then when I run it again, it's going to re-randomize, right? So there's two ways of thinking about that. If it did not re-randomize, I could deterministically find it in 4096 guesses. That's true. If it re-randomizes and we assume an equal distribution of every possible value from 0 to 4096, right, for those 3 nibbles, and I just say, I think it's going to be 12. Right? I have no reason for it to be 12. I think it's going to be 12. Every time we run the program, we're essentially rolling the dice because it's going to re-randomize. And if I re-roll the dice enough times, on average, it will be 12, 1 out of 4096 times. It'll just be the number 12, right? Now, in practice, it may take 2, 3 times this number of attempts for it to actually hit. Because if you know a little bit about statistics, there's a big difference between what is the average expected outcome and then what is the realistic outcome from doing trials, right? From just doing it. There's a high degree of variance. And so we want to cover, I don't know, what is it, 2 standard deviations? Yeah, I'm not a stats guy, but we want to get a good shot at it. And if some stats person hit me with it, they'd be able to tell me exactly how many I'd need to do to be within 2 standard deviations. My answer is run it 3 times this, so whatever that is times 3, yeah, you'll probably hit it, right? If you didn't run it 10 times that, right? It's not that expensive to run the process. If we have a working exploit, our runtime for deploying the exploit and then failing is probably less than a second, right? So even if I have to do 10 times that, 4096 times 10 divided by 60 seconds, oh, that is going to take a little while, isn't it?
It doesn't take 1 second for each iteration.
It's way less than 1 second. Okay, all right. So let's say it takes 1/10 of a second. That's still like an hour, but I think it's actually going to be in microseconds. And so you're going to end up with, just because of the runtime of trying it, you're going to end up with a couple minutes and you could hit it, right? It depends on how, what your time per attempt is, but it's going to be pretty quick. Okay, so Twitch, you are confused, but we will solve your confusion. Why only 3 nibbles? I have 6. So if I go back to this thing, I was looking at this thing right here, which is 136205. The 205, those 3 digits, 205, are fixed and will be constant. I don't need to guess those. The 205 is constant. I never need to guess those. The 3 nibbles that I need to guess is the 6, which is the higher half of byte 2, and then the 3rd byte, which is 2 nibbles. The rest of these that are all 0, I'm just going to inherit from the saved return address. Now, one of the things which I think the original person who asked this question on Twitch, deleting my account in shame, nobody knows who you are except for me. One of the things that I think the person on Twitch realized that I don't know that the class has is, do we need to pick a gadget that has this 4096 brute force possibility? Could we be smarter about it? Obviously, this isn't a particularly interesting gadget, right? It does something crazy. But imagine there was a gadget that I was really interested in and it happened to be here. Do I have to, can I be smarter about my selection of which version of that gadget I have? If you'll recall, by default, ROP gadget does, it only shows us unique gadgets. There is an argument, all, which removes the duplication of gadgets. Disables the removal of duplicate gadgets. So if there was a gadget I was interested in, like, and I'm not saying that this is the right one, but like a lead red or a pop RSP or so something like that, I may be interested in where are all of these, because depending upon where it is will influence how hard is this brute force. Because there may be one that only has a slight difference in the nibbles, right? And so we can actually reduce the amount of brute forcing that's needed by intelligently choosing the gadget. Now that's how I would try and do it if I was working from ROP gadget, right? I'm not saying that either one of these ways are the ways that you should do it. Here's another way of thinking about that same thing, as far as being intelligent on selecting your gadgets, right? So let me find, is this my return address? Right, that's my saved return address. You know what would be the easiest thing to try and brute force? A gadget that's really near this return address. So I could disassemble libc start main. Is there anything useful in here that I might want to do? Right, so one of the things that people said is I could call main again. That's true. So something else I could do along those lines? Like, this doesn't have a very clean ending. Does it have a ret? It's got to have a ret, doesn't it? Yeah. So we could call stack check fail. Right, that would be great. We could call stack check fail leave and then ret. That's a pretty useless gadget. But I'm only looking at this function, right? So I think the smart thing to do is think about what behavior can you trigger that is near the existing return address, because that's going to have the least amount of change required, which means that they are the most likely gadgets that you can trigger. I see you, Twitch. I'm going to say it, and then I'm going to be done talking about level 13. Just because it's not fair if it's just hiding in this like Twitch thing. So, and I hope you don't say any more either. Twitch made this comment that says, I'm going to tell you a secret. You don't need to brute force anything. And that is because it depends on how are you thinking about this return address, and what is the way to reuse the most amount of the existing saved return address in a way that's beneficial to you. I think that was a very useful discussion, and I don't want to say anymore because at that point I'd just be telling you how to do it. So Twitch was satisfied. I think the person in the class that gave me a thumbs up, they're at least thinking. Right? I don't know if they had the epiphany, but they're thinking about it. So anyone got anything else you wanna ask about? Hey, I was poking at this. Look, go ahead.
This was about the previous slide.
Look at the slides. Bam. Up here?
Yeah. It says GDB plugin, right? Are you referring to GDF?
Yes. So for the dynamic allocator misuse, when I say GDB plugin, I'm saying use Jeff or pwn.debug. I actually may end up using pwn.debug in class. I don't know. I have to verify before class which one is going to make sense to me, because at various points in time, functionality of both of them can be broken. The heap functionality is one of those things that can be broken more often than other things. Let me think of something interesting to run. Okay, let's run GDB on ZSH. GDB user bin ZSH. This is totally not ROP related, but okay. So for example, one of the commands that you may want to run, and this, just GDB ZSH, which is a terminal, if you're unaware. So I wanted something that's reasonably complex, because any reasonably complex program is going to utilize the heap in some way, And the command that I ran here, if I find it, with Jeff, they have a command heap bins. There's several heap commands. This is just one to give you an example and why this is something that I would encourage you to look at. So for the next module, this is the first of the series of heap modules on pwn.college. We do not intend on in this class doing the second. The second's way more interesting, but this is a lot more fun. Because like if you haven't messed around with it, it's a nice gentle introduction. Now, the heap is a very complicated machine with many layers and many moving parts. Heap 1 that launches tomorrow at 3 deals with like the first layer that you interact with when you are mallocing and freeing things on the heap. This layer is called the T-cache. And so when I ran this heap bins, there's a whole lot of stuff. Like there's even stuff down here. It's quite a verbose command. But what we are going to be focused on is this T-cache bins. And so heap bins, I think there's a heap T-cache command as well, but or heap bins T-cache. That'll just show you this part. But we'll spend a lot of time looking at this and making sense of this type of a printout. And without having a GDB plugin to like surface this in a pretty way, it's just gonna suck. Because it's like you would have to know where these locations are. You would have to manually dereference all of these pointers and like understand metadata. And like I really am comfortable in GDB. I would still want to have one of these plugins give me a high level view.
This is the Jeff.
This is Jeff that I'm using. Assuming Jeff works, that's what I'm going to stick with. But at one point in time, Jeff was broken with heap stuff, so I'll have to double check as far as does everything work how I want it to work, so that it shows you what I want it to show you. I know pwn.debug's heap functionality, at least as of like 6 months ago, did work well. But that's why I say have a GDB plugin, is because it'll make a lot more sense when we have examples and I'm like, okay, what happened to the heap? And we'll look at changes in this output data to reason about, okay, well, what occurred? Because heap is all about how do we like shift things around, and how do these metadata and things relate to each other, which is a lot easier to understand when you have some type of plugin that will show you that. All right, Twitch, you really want me to go there? You want to hit me with the 15 minutes? We got somebody else. What do we got?
I have a question. Can you do info frame on challenge binary?
On this challenge binary?
Yes.
On 13? All right. So the question was, can I GDB this bad boy? Where do you want me? So he's like, I can info frame, but I'm going to
Anywhere is fine.
anywhere. I think you're going to regret that. Okay. I am inside read for the record.
I was hoping base pointer. One thing that confuses me every time.
Well, what's confusing?
So there is like when you do PRIP, you get an address.
If I P RIP, I get an address.
Then you do XRIP, you get another address.
And then if I do X,
RIP,
yeah, but I have to define how I'm going to format this.
X, the giant X.
Okay. Okay. Examine the giant hex at RIP. Okay.
So the first one is address of RIP register, is it?
Yes. The question was this first one where I did PRIP. This is showing me the value in the RIP register with P, and that is correct. We can verify that by using a more generic command like info-reg, which is display the values in all of the registers. And then we're looking at this first column. We see RIP is AD1F2, P is AD1F2. Right? So P shows me the literal value in the register.
And X shows where it is, that value is pointing to.
You can think of it that way. The statement was X shows me the data that that value is pointing to.
Put the data in memory of that address.
The data in memory at that address. Yes. So the way to think about it, or the way I think about it, is when I type it, I say it in my head. This sounds silly, but I really do. I do the same thing with Vim shortcuts, right? Like there's a word for every key, and so it becomes like its own language that you say to yourself. Right? This is print rip. I'm printing what's in the register RIP. What X is what?
Printing.
Nope. If you say print, it's wrong, right? It's examine. I want to examine the data that is at the location defined by RIP. X is examine. And if I keep those separate, then I'm printing what's in RIP versus I'm examining the giant hex that is located at RIP.
Display same as print.
Display. Yes. So for those that are not GDB aficionados, display is a command where if you're using like bare bones GDB, you can force things to appear every time that you step. Now this is going to look pretty goofy if I have Jeff enabled, because Jeff is already throwing a whole bunch of stuff to my screen. But I could display, for instance, RIP, and that's going to show me what is in the register RIP as I step. And so now every time that I step, it tells me what is RIP. Display uses the print syntax. Set, which is another thing that you use if you are doing like GDB scripting, but you can do it in the interactive terminal as well, also uses print syntax. Right? So now if I print A, we see that it is the same thing as RIP. Right? But all of these, display, set, and print, all use that same syntax. If I wanted to, for instance, set B equal to what is at RIP, I have to either cast it, and let's print that hex. So we see that that's something different, right? This is the hexadecimal representation of what is at the memory location defined by RIP. But I could also, you won't let me print instruction? That's probably for the better, because that would be really insane. But you could cast this to a decimal or something else. But it can get quite messy, right? That's why I'm not saying you have to use Jeff, but it's definitely a nice thing once you understand everything that's throwing at you. Did that answer your question? Okay, cool. So I've got, what, 10 minutes left? Twitch, are you still feeling this, what do I mean with blind ROP? Or are you regretting it? You want to go there? Got to give it a minute. Blind ROP, okay. So, blind ROP is mentioned in one of Jan's, I think one of the Jan's slides. It's either the end of complications or the end of technique. I'm going from memory here. Hacking blind. All right. So the idea here is how do you do ROP when you like have no information? Right. Level 13, we had no information, but we were still able to like reason about it. I would argue that 13 is kind of a blind ROP. Like it's kind of.
In a way, it's not, because it gives you something.
So it gives you something, right? You get this arbitrary read, you get the canary, right? What's that?
You get 2 leaks.
You get 1 leak.
I mean, you can get, in a way.
Well, yeah, but the program ran as intended, gives you one leak. All right, so that's fair. All right, it's not completely blind; it gives you a leak. So okay, Twitch remembered what it meant, but they still want an explanation. So, per the slide, right? A standard blind attack requires a forking service. The idea here is I don't know anything about this, but I can pass it some input, just like how we could brute force a canary byte by byte, which I think we did in memory corruption. Right? We could do that same thing. And then at that point, what's on the other side of the canary? Saved RBP. All right, maybe I care, maybe I don't. And then I can get to save the saved return address. Well, if I don't know ASLR, and I don't know where this thing is returning to, is there a way for me to essentially like fuzz this thing and figure out where is the base address? So in 13, I didn't go on this like great diatribe of oops. Oh, I don't have Jeff. I just did that to myself. I didn't go on like this grand quest to be like, we must find the beginning of libc, right? Why? Because that would be like insanely hard to do. You know, based on where we were in that challenge, it would be hard to do. I think one certainly could do it in that binary. But if I'm brute forcing something and it returns to, we'll say libc, right? Can I figure out the base address of libc purely based upon observable behaviors? This kind of goes back to that reverse engineering module where we had Yon 85, right? We said the last Yon 85 level was you have to figure out all of the encodings, right? And so for people that try to tackle it, they would write this for loop and they would like throw bytes in here and be like, okay, can I reason that this is sleep? Or have I found the bytes that triggered exit? Right? Well, you can apply that same type of reasoning to Rob. Okay? Instead of there being Yon 85 bytes that I'm brute forcing, what I'm trying to brute force here, and again, this requires a fork server, right? So I'm assuming that the memory layout is constant for all of my attempts. Unlike what we talked about before, this blind ROP requires the memory layout to be the same. Because in a fork server, you have your server, it forks, the memory layout is the same as the parent. And you connect again, it forks, the memory layout is the same as the parent. And so you can repeatedly ask these questions or try and brute force this. Twitch says, so we could try and brute force, for instance, the very last byte of a saved return address and see if we get something useful. Sure, you could do that. This is where this intuition that I don't think we overtly state in any of the videos starts to matter. It's what functionality can I trigger that I know I got there, right? With the Yon 85 code, we said, hey, I know there's an exit in here. If I get something to exit with I think non-1, if I remember right, then I know I'm like influencing the behavior. I know where I'm directing control flow. Well, you can apply a similar logic to trying to mess around with the least significant byte or 2 bytes of a return address. If I can somehow overwrite them, and maybe I need to overwrite 2 bytes, right? And I have that 1 in 4096 chance of hitting what I'm interested in. The question is, well, what am I trying to hit? What is something that I could hit that is a clear indicator that I got where I want to? So I'm looking for some type of functionality that like changes the exit code or prints out some constant value that I know. And using that same type of reasoning that I had from level 13, it may make sense to look for functionality that I can trigger that is close to the existing saved return address. I don't want to try and jump from, if say my saved return address is at A00, I don't want to try and jump all the way to DF200, right? That's really far away. I'm going to have lower odds of success here. And very similar to that last Yon85 level, where sometimes you'd put in some bytes and it was just cursed and it would like lock up and not behave correctly. You're going to get that same type of behavior here if I'm like blindly overwriting return addresses and just letting the program return somewhere. Most of the time it will crash. Maybe you end up in an infinite loop. You jumped to a jump. Maybe it just hangs because you somehow jumped to something that triggered read. Right? You're going to get some strange behaviors. And so you're going to have to write code that deals with that, very similar to that last Yon85 level. Blind ROP is, as long as I can reason about the memory space, I can pick somewhere in the region of memory that's contiguous with that return address, which I'm assuming is libc here. I can be like, this is the functionality that I want to be able to trigger. Let's see if I can, if there's a specific location I'm trying to trigger, what do I know as far as my override? So a specific functionality that I may want to trigger, it may be a function, right? It may be a gadget. But what I know is the least significant 3 nibbles are constant. And so I'm fuzzing, or trying to guess these higher order nibbles. Hopefully what I'm targeting is near the existing return address, so I have to guess less. As long as it is a single run of the program, the memory layout will be the same. And eventually, as I exhaust all the possibilities, I will somehow trigger the functionality that I'm targeting. Once I know I have triggered the functionality that I'm targeting, what does that give me? It lets me know that I've hit this instruction, right? It gives me something that's called an oracle. An oracle is some type of primitive where you can send some data, and then based upon the behavior, I'm gaining some piece of information. And so once I've successfully triggered something that say there's some functionality in libc that prints hello world, right? And I fuzz, the first 3 nibbles are fixed. I'm fuzzing these next 3 nibbles. I trigger this functionality and I get hello world to spit out of this thing. Well, now I can start guessing the next byte. There's 256 values that could be that next byte. One of them will result in what? I do a partial overwrite, I get hello world. Now I'm going to try the first 2 bytes plus 1. It does nothing. Now I'm going to try the first 2 bytes and then 2. It does nothing. If I loop through all possible 256 values, say I get to FF, the last try, one of them has to do what? One of them has to print hello world. What did I learn when I see hello world?
This is my.
I've learned the value of the next byte. Can I repeat that process? Yes, I can repeat that process for every ASLR byte until I have leaked the full address of where this mythological hello world function is located inside of libc. Once I've leaked the address of hello world inside of libc, what can I do? I can use that to find the base, and now I can rock the entire libc. So the key problem there is, how do I get the leak, right? As long as it's a fork server, I can target anywhere I want in here, and I have as many guesses as I want. As long as it is, the question was, but does the layout stay the same? If it is a fork server and you haven't killed the fork server, then the memory layout will be the same. And so I need to find some functionality that I can trigger where I know I'm hitting something, right? And so I know where this is. And then based upon going 1 byte more, does that same behavior occur? Then I found the next byte. And we can utilize that functionality to leak some libc address. And all I need to successfully ROP or like defeat ASLR is a single leak. And so we have to blindly create this primitive that lets me leak a libc address, as I don't want to say via side channel, but kind of. And then once I get the libc leak, it's game over. We've already figured out how to apply a leak. My suggestion for the levels that has a blind ROP is to use that pwn.college ROP functionality, right? Once you've set the base address of that ROP object, then you can have pwn.college rock and roll and do the math for you. All right. Twitch thanks me. I think it was a good time.
I have
One last question. We are over time, but I'll see what I can do.
Why there was no base address RPP? There should be some RPP, right?
The question is, I run this and I just randomly did info frame here. There's no RBP. There's no saved RBP. Is that correct?
Yeah.
All right. Well, why is that? The answer is because the function doesn't push a saved RBP.
Do we have stack at this point?
So a requirement of there being a saved RBP is that we push RBP. We don't push RBP here, right? It turns out you can compile binaries, whether it's userland or a library, and here we're inside libc's read functionality. But you can totally build a binary that doesn't rely on RBP. RBP is actually an optional thing. And if you are running something that's like super performance oriented, does it make sense to have this push RBP and then pop RBP at the end? Or is that extra work? It's extra work. It's an extra instruction that you don't actually need. Because you can reference local variables on the stack from 2 locations. One is RBP. What's the other? RSP. And so if we look at this libc read function, how does it access local variables? They're all via RSP. That's a compilation option, which, somebody actually knows it. It's -f omit frame pointer. You can pass that to GCC, and it will cause the binary to reference local variables relative to RSP instead of RBP. At that point, we're not using RBP for stack math, right? And so there's no need to push it. There's no need to pop it. And so that's less work on the actual CPU. Now, in userland, in most cases, it doesn't make sense to enable that compilation option, because one of the nice things about having RBP is it allows us to very easily get a backtrace and understand where our function frames. You can still do it technically without RBP, but it's definitely a lot cleaner and easier to analyze the stack when there is an RBP, because then you have like from here to here is a stack frame, from here to here is a stack frame, right? If you don't have RBP in your binary, instead what you have to look at is you have to analyze the actual assembly code and be like, okay, what happened to RSP, right? How far did RSP go down? And you have to figure that out. I don't want to call it like dynamically, but you're essentially running the assembly to figure out where all the function frames are. So sometimes you'll have it, sometimes you won't. I don't think it's the end of the world. It's a good question, though. All right, with that, I'm over time. We'll leave it there. I will be around here on Friday. for office hours if you need me. With that, I'll leave you. Goodbye. Good luck. Have fun.